Okay, welcome to chemistry classes. In this video, we have to discuss here separation of mixture, filtration, distillation, chromatography, and sublimation. This type of different type of separation of technique we have to discuss here. Okay, so we know there are different type of mixture, homogeneous mixture and heterogeneous mixture. We discussed in previous video, we discussed heterogeneous mixture and homogeneous mixture. Heterogeneous mixture means different components of mixture do not mix homogeneously. That is heterogeneous mixture. Example for heterogeneous mixture: sand in water, chalk powder in water. Heterogeneous mixture. Homogeneous mixture: different components of mixture mix homogeneously. Example: salt in water, sugar in water. These are example for homogeneous mixture. Heterogeneous mixture we can separate very easily. For example filtration, sieving. This type of technique we can use. Okay, heterogeneous mixture we can separate by simple hand picking method, sieving, filtration. Simple hand picking method mean we have one heterogeneous mixture, we can simply separate with hand. Some type of mixture we can separate such like this. This type of method is called simple hand picking method. Clear? Okay, after this we have to discuss here filtration. I told you heterogeneous mixture, example sand in water, we can separate by filtration. For filtration we will use filter funnel. We will use this type of one funnel. This is called filter funnel. On the top of filter funnel we will keep filter paper. Okay, and we will put the mixture from the top of the filter funnel. All solid will stay over here, only liquid will come down. The solid which stay on the top, it is called residue. For example, when you put sand in water, when you put sand with water on the filter funnel, sand will stay over here, only water will come down. The sand which stay on here, the sand or residue, the residue which stay over here, it is called the solid which stay over here, it is called residue. Water, the liquid state which came down, it is called filtrate. This method is called filtration. So the special apparatus used for filtration, filter funnel. Okay, so remember here filter funnel, residue and filtrate. Okay, and this is one example for heterogeneous mixture. Okay, next one we have to discuss here separation of colored components from blue or black ink. We have blue or black ink. From this ink we have to separate different components of mixture. Okay, so here we have to discuss which are the different procedure to separate different components of colored components from ink. So for this purpose we have to take a beaker with water and cover the beaker with a watch glass and put few drops of ink on the watch glass. So see here in this diagram, here we have to take a beaker with water and cover the beaker with a watch glass and put few drops of ink on the watch glass. Then heat water. Okay, do not heat ink directly. Okay, do not heat ink directly. We have to keep watch glass over here and heat water in the beaker. Okay, because of this heat, ink from watch glass get hot and it start to evaporate. Okay, after finished evaporation from the ink, we will stop heating and we will get residue from here. We will get residue from the watch glass. So here ink is a mixture. Ink is a mixture. Mixture means impure substance. We discussed in previous video. Mixture, it is impure substance. Compounds, the substance which contain only one type of substance, only one type of elements or only one type of compounds. These are pure substance, but mixtures are impure substance. So see here, ink, it contains different colored components, also something evaporated over here. So here it is mixture. Okay, so this mixture we can separate by this method. Take water in a beaker, cover a watch glass on the beaker and put few drops of ink on the watch glass and heat water directly. Do not heat ink directly. Okay, and here ink from watch glass will be evaporate. After evaporation finished, we will stop heating. Okay, then we will obtain residue from the watch glass. Okay, so this is the method to obtain colored components of ink. Okay, colored components, or you can say different dyes from the ink. Okay, we have to discuss here separation of cream from milk. How to separate cream from milk. Okay, to separate cream from milk, we will use centrifugation. Centrifugation means the mixture rotate very fastly. Okay, the mixture rotate rapidly in a particular machine called centrifugation machine. To separate cream from milk, we will use this method, centrifugation method. Centrifugation means the mixture rotate very rapidly, so we can separate cream from milk. Okay, this is the apparatus used to separate cream from milk, or this is the apparatus used for centrifugation. Okay, and here mixture rotate very rapidly in this type of machine. Okay, and here application for centrifugation. Here these are the different application in centrifugation. To test blood and urine. Okay, diagnostic laboratory using centrifugation to test blood and urine sample. Okay, and another one, to separate butter from cream. To separate butter from cream, also we will use centrifugation. Also another one, this method also used in washing machine. Washing machine to squeeze out water from wet cloth. Okay, to dry cloth in washing machine, we will use this method. Cloth will spin rapidly. Okay, so it helps to drain cloths, to squeeze out water from wet cloth. Okay, so these are the different applications of centrifugation. Okay, so cream from milk, butter from cream, this type of separation we will use centrifugation. Centrifugation means the mixture rotate very fastly and helping to separate cream and milk, or solid and liquid. We can separate this method. Okay, one we have to discuss here, separation of immiscible mixture. Immiscible mixture or immiscible liquids mean two liquids do not mix each other. Two liquids do not mix each other. Such type of liquids are called immiscible liquids. This mixture can be separated with help of separating funnel. You can see here separating funnel. Okay, so this type of funnel we can use to separate immiscible liquid. Immiscible liquid example, oil in water, kerosene in water, they do not mix each other. These are called immiscible liquid. Okay, so take immiscible liquids in separating funnel and shake well, then keep it one place. Okay, let it stand undisturbed, means keep this in one place and do not disturb, do not shake it. Okay, then it forms two separate layers. You can see in this diagram, it forms two separate layers. After that, you have to open the stop cock. Okay, then pour out the lower layer. take out the lower layer of the liquid. This is the method to separate immiscible liquid. To separate immiscible liquid, we will use separating funnel. Okay, separating funnel. And application for this process. This process helps to separate oil and water. This process helps to separate oil and water. Also, this process applicable in extraction of iron. In the extraction of iron, also we will use this type of separation. Okay, separation of immiscible liquid. Okay, extraction of iron, and another one, separation of oil and water. Extraction of iron you will study in higher classes. Okay, during extraction of iron it form molten iron, also it form molten slag. Slag mean impurities in the iron. So there will be two separate layers. These two separate layers can be separate, okay, with help of separating funnel, because they are immiscible liquid. Okay. Next one we have to discuss here, separation of salt from ammonium chloride. Salt and ammonium chloride, how can we separate? We know ammonium chloride, this type of solids will sublimize. Here ammonium chloride, iodine, camphor, this type of solid will sublimize. Sublimize means this type of solid directly change to gas without change to liquid state. They will directly change to gaseous state. Solid directly change to gaseous state. This process is called sublimation. So we have a mixture which contains salt and ammonium chloride. Okay, so you have here one picture. Here salt and ammonium chloride. We have to take salt and ammonium chloride in a china dish and invert a funnel as shown in the figure. Invert a funnel on the china dish. Okay, then put some cotton plug on the tail of the filter funnel. Then heat china dish. We know ammonium chloride, it will sublimize, it will change to vapor very easily, and this vapor will condense on the surface of funnel, but salt will remain on the china dish. By this way we can separate the mixture of salt and ammonium chloride. So here I will say once again, we have to take the mixture in china dish. Okay, invert a funnel as shown in the figure. Invert the funnel. On the tail of the funnel we have to put some cotton plug. Heat the mixture. Okay, after that ammonium chloride will sublimize, and after sublimation we know ammonium chloride will change to vapor. This vapor, ammonium chloride vapor, will condense on the surface of filter funnel. It cannot escape outside because the tail of the filter funnel we covered with cotton plug. So this vapor do not escape outside. It will condense back on the surface of filter funnel. But salt will stay on china dish. Okay, this method can be used to separate salt and ammonium chloride. Also see here, how can you separate salt and iodine? How can you separate salt and camphor? Same process we can use. Okay. Okay, next one we have to discuss here, chromatography. Next method of separation, chromatography. Chromatography is a method of separation to separate colored mixture. Colored components or colored mixtures can be separated with help of chromatography. Chrome means color. Okay, so chromatography used to separate colored mixture. For chromatography we will use a special type of paper called chromatographic paper. Okay, also we can do this experiment with the help of normal filter paper. So take out a filter paper. This is the size of filter paper we will use to chromatography. Okay, around 12 centimeter length and 3 centimeter width. Take this type of chromatographic paper, and lower end Lower end of this paper we have to draw a line with the pencil. Okay, pencil. Do not use ink pen, because this chromatographic paper we have to insert into water. Okay, when you draw with ink pen, and it will give you wrong answer, because we have to separate colored substance. Okay, so ink, it contains colored pigments, so there is a chance to get wrong answer. That's why we have to draw this baseline with pencil. Okay, after that we have to put the sample, the mixture, the sample mixture. Okay, we have to put 1 drop of sample mixture on the baseline as shown in this figure. Okay, after that we have to insert this chromatographic paper into a beaker which containing water. Okay, we have to make sure that this baseline should be above the surface of water. Do not insert baseline and sample drop into the water. It should be above the surface of water. Okay, and you can see here in this video, you can see here, I will show you one video after this. You can see here chromatographic experiment. So here in this video you see here this colored components will move upward, it moving upward, because this is filter paper. This water will rise upward through the filter paper, and this water helps to separate different components of colors from the sample which contain different components of color, and it will separate into different spots or different pigments, okay, with the help of this water. This process is called chromatography. Look here at the end, we have to say this is the result of chromatography. We will say chromatogram. This is the result of chromatographic paper. Imagine our sample which contain 2 pigment. So we will get here 2. We will get here 2 spot. Imagine our mixture which contain 4 pigments, 4 different colored pigments. So there will be 4 spot. Okay. Here this is our sample mixture. It contains 4 pigments. So it form 1, 2, 3, 4 spot, and this result is called chromatogram. Okay, so these are the things we have to discuss about chromatographic experiment. This experiment used to separate colored components, and here we have to use a special type of paper called chromatographic paper. And here the size of chromatographic paper around 12 centimeter length and 3 centimeter width, and the lower end of this chromatographic paper we have to draw a line with the pencil called baseline, and put one drop of mixture on the baseline and insert this chromatographic paper into a beaker which containing water. Okay, and this water will move upward through the chromatographic paper, and this water helps to separate different components of mixture. Okay, and this process is called chromatographic experiment. This chromatographic experiment, applications of chromatographic experiment. Chromatographic experiment helps to test purity of food and drugs. We can check purity of food and drugs with help of chromatography. Also here we discuss different colors of colored components from dyes. Dyes mean it contains different colored components. We can separate different colored components of dyes with help of chromatography. Okay, pigments from natural colors which contain different pigments. For example, chlorophyll, it contains natural pigment, green pigment. We can separate this pigment with help of chromatography. Okay, so these are the different applications of chromatography. Because here separation of miscible liquids. We already discussed separation of immiscible liquid by separating funnel. Okay, next one, separation of miscible liquids. Miscible liquid means two liquids mix each other. For example, acetone in water, ethanol in water. This type of mixture we can separate by this method. It is distillation. We will use another term, distillation, to separate miscible liquid. There are two different types of distillation. Distillation means the process by which we will separate miscible liquids. Miscible liquid means two liquids mix each other. Example, alcohol in water, acetone in water. Okay, so this type of mixtures are miscible liquids. Okay, so here distillation. There are two types of distillation we will discuss, simple distillation and fractional distillation. Simple distillation and fractional distillation. These are the two different types of distillation. Okay, so let us see here, this is the apparatus used for distillation. For distillation we will use a special type of flask, round bottom flask. Bottom part of this flask is round shape. That's why we will say round bottom flask, RB flask. Okay, or we can say distillation flask. Also we can say distillation flask. So we will take the mixture in this flask. We will take the mixture in round bottom flask. Okay, and we will heat the mixture over here. We will heat the mixture here. Okay, after heating mixture, we discuss here immiscible liquid mean two or more liquids, two or more components. So components with a low boiling point will change to vapor. Component with a low boiling point, it will change to vapor. And this vapor will come over here. This apparatus is called condenser. This apparatus is called condenser. Okay, so after heating, the component with a lower boiling point, it will change to vapor, and this vapor enter in condenser. Okay, in condenser it is a special type of apparatus. It used for cooling. To cool the vapor. Okay, after cooling this vapor, again we can change back to this vapor into liquid state. Okay, so liquid acetone or liquid alcohol, the component with the low boiling point, again it will change to liquid state. This way we can separate miscible liquid. So here this is condenser. Look here, this vapor will come here. Here this is one apparatus. Inside there is a tube, inner tube. Inside that tube there is vapor. Outside there is a covering. Okay, through this covering we will pass water. This here water in and here water out. We will pass water through the condenser here, and water will be outside. We will collect water outside here, and this water helps to cool vapor inside the condenser. Condenser used to cooling. We know after heating the system gain energy. Sometimes you have the question, where this system gain energy? Here in RB flask system gain energy because we heat over here. Where this system losing energy? After cooling the system lose energy. We cool over here, the condenser cooling. So here in condenser system losing energy. Okay. So this is also here we will keep thermometer here. This is thermometer. This thermometer helps to control temperature. We heating over here. Okay. So to control temperature, we will note the temperature over here in the thermometer. For example, we have the mixture which contain water and alcohol. Alcohol will boil at 70 degrees Celsius. Water will boil at 100 degrees Celsius. So we will heat over here and we will maintain the temperature around 80 degrees Celsius. Around 80 degrees Celsius. Clear? So around 80 degrees Celsius, water boil 100. Alcohol 70. So at 80 degrees Celsius all alcohol changes to vapor, but water stay over here. At 80 degrees Celsius water do not boil, it need 100 degrees Celsius. So water changes to alcohol changes to vapor, and this alcohol vapor will be condensed by condenser and we can collect alcohol over here. This method is called distillation. Okay. So also I told you there are two different type of distillation, simple distillation and fractional distillation. Fractional distillation mean the different components of the mixture, their boiling point very close each other. Boiling point of different components of mixture very close each other. So we have to use fractional distillation. Very close each other mean different components of mixture, their boiling point difference less than 25 Kelvin. For example, alcohol and water will boil 100 degrees Celsius. Alcohol will boil 70 degrees Celsius and water will boil around 100 degrees Celsius. So their boiling point difference around 25 Kelvin. Okay, around 25 Kelvin. So we can use fractional distillation. Also another example, acetone and water, their boiling point difference very close each other. Okay, their boiling point difference, their boiling points are very close each other, not big difference. Okay, big difference mean different components of mixture, their boiling point big difference, then we have to use simple distillation. Okay, in simple distillation, example for simple distillation, seawater. We want to obtain pure water from seawater. So we will heat very strongly, water will change to water vapor, and pure water we can collect after condensation. Okay, this is simple distillation. Also all impurities will stay on the distillation flask. So their boiling point difference much bigger. So we have to use simple distillation. Acetone in water, alcohol in water, or you want to separate oxygen and nitrogen from air. So we have to liquefy air. We have to change gaseous air into liquid state air. Then we will warm this mixture. We can separate oxygen and nitrogen. Okay, liquid air, we can separate oxygen and nitrogen. Their boiling point very close each other. So we have to say it is fractional distillation. Okay, in fractional distillation there is one more apparatus over here. Okay, fractionating column. You can see in this figure fractionating column, also glass beads over there to increase their separation. Okay, For simple distillation, you can see only this figure. You can see only this one. There is no fractionating column and glass beads in simple distillation. Only fractional distillation, you can see fractionating column and glass beads to increase their separation. Okay. Next one we have to discuss here, separation of different gases from air. Okay, to separate different gases from air, we know gas it is air, it is gaseous state. We have to convert gaseous air into liquid air. We have to convert gaseous air into liquid state, applying very high pressure and very low temperature. Reduce temperature and apply very high pressure. We can change air in gaseous state to air in liquid state. Look here when you apply high pressure and very low temperature, here oxygen will change to liquid state very fast, minus 183. Okay, but you have to reduce temperature very low to convert nitrogen into liquid state. Okay, so here first oxygen will change to liquid state, then argon, then nitrogen. This is the order different gas which change to liquid state. Okay, we have to reduce temperature very low to change nitrogen to liquid state. After that we have to warm this mixture. After warming, again oxygen will change to gaseous state first. Oxygen will change to gaseous state first, then argon, then nitrogen, because nitrogen at a very low temperature and we have to warm little bit, we have to warm more to change to gaseous state. So here you remember nitrogen will change to liquid state very last. Also nitrogen will change to gaseous state also last. Okay, but oxygen will change to liquid state first. Also oxygen will change to gaseous state first, because of here lower temperature oxygen change to liquid state. At lower temperature also we can change to oxygen in gaseous state. So here this method is called a fractional distillation. Fractional distillation, why we use here fractional distillation? Because different components of mixture, their boiling point close each other, not much difference in their boiling point. So we have to say here this process is fractional distillation. Okay, and also here we have to apply very high pressure and very low temperature, then only air gaseous state change to air in liquid state. Clear? Okay, next one we have to discuss here purification of copper sulfate. Okay, purification of copper sulfate. To purify copper sulfate from impure copper sulfate, we will use crystallization. We will use the method crystallization. This is another method to purify sample, to purify mixture. Crystallization. See this video, I am giving you one video related to crystallization. So using this video you can understand here crystallization method. Okay, so here different methods for crystallization. Here we have to dissolve, we have impure copper sulfate. Okay, take this impure copper sulfate and add into water, shake well. Okay, and copper sulfate will be dissolved in the water, separate or remove undissolved impurities by filtration. Take out impure copper sulfate sample, add into water, shake well. Copper sulfate will be dissolved in water, remove undissolved impurities by filtration. Warm this mixture. After filtration we will get filtrate. We will get the mixture which contain dissolved copper sulfate. Warm this mixture to get saturated solution. After warming, some water will be evaporate out and we will get saturated solution. Okay, saturated solution, we discussed the previous video, saturated solution. Okay, so this saturated solution, take out this saturated solution and cool this saturated warm solution slowly. After that we can see copper sulfate crystals are formed. Copper sulfate crystals are formed. Take out the copper sulfate crystals. You can take out this by filtration. Okay, so these are the different methods for crystallization. Okay, dissolved impure copper sulfate in water, remove undissolved copper sulfate by filtration, evaporate the filtrate to get saturated solution. Then cool the saturated solution slowly in room temperature and we can see crystals of copper sulfate formed in saturated solution. Take out this copper sulfate crystals by filtration. Okay, and these are the different methods of crystallization. Next one, we have to understand here applications of crystallization. What are the different applications? Here, purification of salt from seawater. Purification of salt from seawater. We can purify by crystallization. And another application, suppression. Suppression of alum. Separation of crystals of alum from impure sample. We can separate it by crystallization. These are the different applications. Clear? Okay, next one we have to discuss here purification of water. Next one we have to discuss here purification of water. To purify water, there are 4 different steps to purify water. Okay, first one, simple hand picking method. Simple hand picking method, sedimentation, filtration, chlorination. These are the different methods to purify water. Water kept in a reservoir, water kept in a large tank. Okay, it contains solid impurities. It contains big solid impurities like stone, leaf. This can remove by hand, by simple hand picking method. Okay, next one, sedimentation. Water which contain, after sedimentation, again water which contains small impurities we cannot remove by hand picking. We cannot remove by simple hand picking method. This type of impurities can be removed by sedimentation. Sedimentation means after removing big solid impurities, we will add some setting agent. We will add some setting agent. We will add some chemicals such as aluminum sulfate. We will add some chemicals like aluminum sulfate into water. Then shake well. All small impurities will be settled down. All small impurities will be settled down. Okay, this method is called, this step is sedimentation. After sedimentation, we have to conduct filtration. We will pass water through a sand bed, thick sand. Okay, so we will pass water with small impurities through sand bed. Okay, all small impurities will stay on the surface of sand. Pure water will, you can collect pure water from down part of this filter. Okay, we will obtain filtrate but all small impurities will stay on the surface of sand. This method is filtration. For filtration, we will use a big thick sand because we have much more amount of water. We will purify water from river or large reservoir, large tank. Okay, so large quantity of water we have to purify here, so we have to use this method. After that, last step to purify water, chlorination. We will pass chlorine gas to after filtration. We will pass chlorine gas through the filtrate. This chlorine gas, it helps to kill germs and bacteria. That's why we will do here chlorination. So these are the different steps to purify water. Simple hand picking method, then sedimentation. Remember here, aluminum sulfate used as sedimentation, aluminum sulfate used as setting agent. Okay, simple hand picking method, sedimentation, filtration, chlorination. Okay, next one we have to discuss here, physical change and chemical change. Okay, physical change and chemical change. Melting, boiling, freezing, sublimation, condensation, this type of change we discussed in first chapter. Melting, example, ice changed to water, water changed to water vapor. You know, ice, water, water vapor, all this case they are chemically not changed. Always they are H2O. H2O in liquid state, H2O in solid state, H2O in gaseous state. Okay, chemically not changed. Only physical state, the state of matter changed, but chemically not changed. Such type of changes are called physical change. Physical change means no new substance formed, new substance not formed at all. Okay, only the state of matter change. Such changes are called physical change. For example, melting of water, melting of ice, boiling of water, freezing of water. Always the state of matter change, but chemically not change. Also, new substance not forming in physical change. Okay, example here I told you, boiling of water, melting of ice. Also cutting of trees. You cut trees into small pieces, new substance not formed. Okay, there is no states of matter. Even you cut tree, big piece of wood changes small pieces, solid state, but state of matter not changing, even it is physical change. Okay, before cutting it is wood, after cutting also it is wood, not new substance formed. So it is physical change. Also you remember here, mixtures are formed by physical change. Mixture, for example, salt in water. You dissolve salt in water, sugar in water. So all these are formed by physical change. Okay, mixtures are formed by physical change. So physical change means change by which no new substance formed, also no chemical reaction. Clear? After that, we have to remember here, we have to discuss here chemical change. Chemical change means opposite of physical change. Chemical change means new substance formed. Okay, also after chemical reaction, chemical composition will be changed. For example, burning of wood. Wood after burning, it will change to ash and something other new substance are formed. So it is chemical change. Burning of wood, burning of paper, burning of fuels, all these are example for chemical change. Okay, and another thing, something reacting with the acid, metal react with the acid. Okay, zinc reacted with acid or calcium reacted with the acid. Also, these are example for chemical change. Chemical reaction means new substance will be formed. There will be chemical reaction. Also, compounds, also pure substance are formed by chemical change. We discussed mixtures are formed by physical change, but mixture mean impure substance. Impure substance are formed by physical change, but here pure substance, compounds, elements, these are pure substance. Pure substance are formed by chemical change. Okay, so here we discuss physical change. Okay, physical change means change. There is no chemical composition change. Also, there is no chemical reaction, no new substance formed. Boiling, melting, freezing, cutting of trees, these are example for physical change. Then chemical change. Chemical change means new substance will be formed. There will be chemical composition change. Okay, pure substance are formed by chemical change. Okay, burning of fuels, burning of paper, also metals react with acid. These are example for chemical change. Burning of candle, you know candle wax, it is solid state. When you burn this, it will melt, it will change to liquid state. So solid change to liquid state. There is physical change. There is physical change. Also it is burning of candle. So also there is vapor is formed, new substance formed. So it is chemical change also. So burning of candle, both physical change and chemical change. Next one, we have to discuss here classification of substance. We can classify substance. There are two different types of substance, pure substance and impure substance. Impure substance already we discussed. Impure substance are mixtures. Mixtures are impure substance. There are three different types of impure substance: solution, suspension and colloid. We discussed more details about this. We discussed already impure substance. Now we have to discuss here pure substance. Pure substance we can classify. There are two different types of pure substance: elements and compounds. Elements and compounds, these are different type of pure substance. Elements means substance which contain only one type of atoms. Substance which contain not one atom. Substance which contain only one type of atoms. That is elements. Example, you take one gold bar. Imagine this made of gold. So only gold atom here. So this is element. Imagine this room contain only oxygen gas. So here only oxygen atoms. So this is element. Okay, so elements mean only one type of atoms. That is element. Okay, next one, compound. Compound means substance which contain two or more different atoms chemically joined together. Example, water. Water is a compound. There is two different atoms, hydrogen and oxygen, chemically joined together. It is compound. It is important to say chemically joined together. You take one cylinder, you just mix hydrogen and oxygen. There is no any chemical bond between hydrogen and oxygen. Just mix hydrogen and oxygen. So you cannot say it is chemical, you cannot say it is compound, it is mixture. Hydrogen and oxygen chemically joined together, then we have to say it is compound. Okay, so compound means two or more different atoms chemically joined together. It is compound. H2O, it is compound. Glucose, C6H12O6, carbon, hydrogen, oxygen, different atoms chemically joined together. It is compound. So this is element and compound. Elements and compounds are example for pure substance. Elements, again we can classify metal and non-metal. Metals, silver, gold, platinum, iron, copper. These are example for metals. Non-metals, carbon, sulfur, nitrogen, oxygen, hydrogen. This type of elements are non-metals. So elements you can classify metals and non-metals. Okay. You know metals like iron, silver, gold, platinum. These are metals. Metals are very hard. They are shiny. They are sonorous. Sonorous means metals produce sound. When you put down metals, it produces sound. Or you beat two metals together, it produces sound. So you can say it is sonorous. Metals are sonorous. Okay, metals are shiny. Metals are good conductor of heat and electricity. These are the some properties of metals. But generally, non-metals are poor conductor of electricity and heat, except carbon. Carbon, it is good conductor of electricity. Carbon, graphite, it is good conductor of electricity. But except carbon, generally other non-metals are poor conductor of electricity. Okay, they are dull, they are not shiny, they do not produce sound, they are not sonorous. These are the general properties of metals and non-metals. We will study more details about this. Later. Okay, so here you just understand few properties of metals and non-metals. I told you compounds and mixture. Compounds are pure substance. Compounds are pure substance, compounds which contain two or more different elements chemically joined together. Compounds are formed by chemical reaction. Compounds are formed by chemical reaction. It is also, it is compound. For example, H2O, 2 hydrogen and 1 oxygen. So they have fixed composition. Their components must be fixed. H2O, 2 hydrogen and oxygen. If you put H2O2, it is not water. So in compound, their different elements are fixed. Different components of compounds are fixed. Okay, and these compounds are formed by chemical reaction. It is pure substance. Okay, different components of compounds you cannot separate by physical method. You cannot separate hydrogen and oxygen simple physical method, like we discuss many methods, filtration, distillation, chromatography. This type of physical method you cannot separate compound. Okay, these are the things we discussed in compound. Compounds are formed by chemical reaction. Okay, and new substance formed here. Okay, fixed composition here. Also different constituents we cannot separate by filtration. But here mixture, it is impure substance. Mixtures are formed by simple mixing without chemical reaction. No new substance formed. Different components of mixtures can be separated by physical method. For example, salt in water, it is mixture. We can separate by evaporation. Okay, new substance not formed. Okay, also here no fixed composition. You take 1 glass water, put 1 teaspoon sugar, shake well, it is mixture. Also you take 1 glass water, put 2 teaspoons sugar. Okay, so these are the things we discussed about mixture. Mixtures are formed without chemical reaction by simple mixing. No new substance formed. Okay, there is no fixed composition. Also it can be separated by physical method, filtration, distillation, or this type of method we can use to separate mixture. So these are the things we have to discuss over here. Clear? Thank you for watching this channel. Please subscribe and press the bell icon for more videos. Thank you.